Hello friends, my name is Joy. If you are a student who has successfully completed the class 10th board examinations and want to pursue the science stream with dreams of becoming doctors, engineers or scientists, then this video is for you. As you must have heard from your elders that in these 2 years of your higher secondary life, there is an ocean of things to learn, a lot of efforts to be put in, and a proper guidance so that you don't do mistakes. Now if we count on the number of institutes that provides this guidance in the form of coaching, then that number is probably going to be more than the number of seats available in the IITs in a year. A new venture in this regard must have a good reason to be, and a good reason we do have. Generally it is seen that such institutes are fully focused on the entrances, which we call as the full-fledged coaching centers, or they are primarily focused on the board exams, which we better call as tuition centers. What we have to offer in KRISHNA coaching is the dual task of providing guidance in both these areas, where students will be trained to write long subjective answers, and simultaneously they will also be taught shortcut tricks to handle the MCQs. So this is going to be the one-stop solution to help you come out in flying colors at the end of your class 12. So without any delay, let's start the class. Welcome back. In this lecture, I'm going to take an important topic from class 11 physics, that is projectile motion. And through this lecture, I'm going to show you how we can take things from a very naive level to the level of problem solving. So to understand this, let's do a thought experiment. Let's imagine that we are 1000 years back in time, where physics was not that much developed, and we are just a keen observer of nature. Okay, now let's start the thought experiment. Imagine there is a car which is at rest, and there is a provision in the car through which you can throw balls up in the air. So it's some kind of a cannon like structure. Now if this car is at rest and I ask you what will happen to this ball after some time, all of you will say that, well, we experience this every day. The ball will come back to the point where it was thrown. So this is not surprising to us. Now if I change the situation and say this car is moving with a constant velocity towards the right, and I throw the ball at this point of time in the upward direction. So what will happen now? Some of you may say that, well, we had released the ball at this point, so this will go up and come down along this way. Some of you will say that since the car was moving, the ball will also have some horizontal velocity. As a result, instead of coming to this point, it may fall somewhere around here. But when we actually do this experiment, we'll find that the ball will exactly come to the point where it was thrown, the point of the car from where it was thrown. This is surprising, isn't it? Now at that point of time, imagine we are 1000 years back in time. This was surprising for people, that if something is moving with a velocity in the horizontal direction and a ball is thrown up in the air, then the ball will fall exactly to that same point from where it was thrown. Now if I ask you a question, that the second case may be surprising for you, but the first case was not. Let us relook at the first case. In the first case, although the car was stationary to our eyes, but the car was standing on the surface of the earth, right? And earth moves with a very high velocity, a very high linear velocity, which is 450 meters per second. Now if the ball takes around 5 seconds to reach back to the car, then in those 5 seconds the earth has actually traveled 2 kilometers. Or in other words, the car which is on the surface of the earth, that has also traveled for more than 2 kilometers. So that means the car was moving then also, but still the ball came back. And this was given as an argument by people who believe that the earth was stationary. Their question was that if the earth was moving, that how come the ball thrown up in the air comes back to the same point from where it was thrown? Are you getting this point? So because of these confusions, we had to design some new physics that we are going to study now. But before that, let's go to one more scenario. let's consider there is an aeroplane and it is dropping a parcel to the ground below. Okay, now at this point the parcel is released. Now it's quite obvious that the parcel will come down, but the question is, what is the trajectory that this parcel will take while coming down? Okay, naively thinking, you may think that it was released at this point, so it will come down straight. But some of you may say that no, it may have some horizontal push, so it may come down like this. But when you actually do this experiment, you will observe something like this. And if you are thinking yourself to be 1,000 years back in time, this is something that must surprise you. That is, at every point of time, the parcel is exactly below the plane. Or in other words, if you are looking at this parcel from the plane, or let's say through the window of the plane, you will see that the parcel is always below you. That means as if it is moving vertically downwards. Now, because of this acceleration due to gravity, this parcel is having some vertical acceleration. That is fine. But if you consider the case in the horizontal direction, this parcel is behaving as if at every point of time it is inside the plane, because in the horizontal direction both the parcel and the plane are at the same along the same line. So this was something also surprising to people. Why, after releasing as well, that this parcel is not directly falling down, but instead it is moving at the same velocity at which the plane was moving, assuming that the plane is moving with a constant velocity. So these were confusions among people, and we had to design some physics so that which will explain us what is actually going on in these scenarios. So what is obvious from these experiments is that there is a horizontal velocity. If something has a horizontal velocity, then that remains unchanged. In the previous example, you saw the ball, whatever amount of distance it was moving in the horizontal direction, that was not changing. That's the reason it has fallen back to the same point. Similarly, in this case as well, the parcel's horizontal velocity is not changing. Gravity is accelerating it in the vertical direction, but in the horizontal direction it is maintaining its original horizontal velocity. So that means horizontal velocity tells to gravity that I don't care about you. Okay, and like in the meantime, the gravity's situation will be like, this is a small parcel and it is like falling down and it has a small horizontal velocity. I am the big fat earth pulling this, but this horizontal velocity is something which just don't care for me. So gravity's situation can be depicted something like this. Moving ahead, let's now consider a situation. So in the previous section we have learned that the horizontal velocity does not care about the vertical velocity or the vertical motion. Let's now consider the reverse scenario, which is possible, that the vertical motion does not care about the horizontal motion. For that, we have to do an experiment. We take two balls, one red and one black, and we just throw the ball in the following manner. The red ball we just drop, and the black ball we just throw it with some initial horizontal velocity. What we will observe is this: the red ball which was dropped, it will directly fall down, and the black ball which was given a horizontal push, it will follow a trajectory like this, and both of the balls are released simultaneously at the same time. Now we will see that because of this horizontal push, this black ball is getting away from the red ball. Okay, but if we see something else, it will surprise us that at every point of time, at a vertical level, both the balls are in the same vertical height at each point of time before they strike the ground. So at any point of time, if we take a snap, we will find that the heights of both the balls are exactly the same. So this says that it's not only that the horizontal velocity does not care about the vertical velocity, but the vertical velocity also doesn't care about what is happening in the horizontal direction, how far apart they are going. because at the vertical heights, the vertical heights are always the same. So that means if we just read these lines, vertical motion remains unchanged in this case, and whatever motion that we consider where they are both the horizontal and the vertical directions are involved, then the total motion is the combination of both the motions, and we have to do a vector sum of them. And these two motions, that is the horizontal motion and the vertical motions, they are independent of each other. So vertical velocity will revert back to horizontal velocity, saying that I have taken my revenge. It's not that you don't care about me, I also don't care about you. That means the horizontal motion and the vertical motion, these are two independent quantities, and they are not, one cannot change the other. So that is the thing we have to understand from all these experiments. So let's summarize what we were doing. In case of a projectile motion, when we throw something which has both a horizontal direction as well as a vertical direction, then these two can be treated separately, okay? And once we are done treating them separately and calculating the necessary physical quantities, we just need to combine them using vector addition rules. So that's the crux of the method that we have learned till now. Let's move forward to the mathematics parts now. So if you throw a projectile at an angle, at certain angle from the ground, okay, with an initial horizontal, sorry, not horizontal, with an initial velocity u. So this is how we depict a projectile. That means you are standing at some point, okay, and you are throwing a ball into the air at an angle of theta from the ground, and the initial velocity that you are providing to the ball is u, okay. So the first task that we have learned from the previous section is that the first task is to separate these motion into two parts. One is along the x-axis, which we call as a horizontal motion, and one is along the y-axis, that is a vertical motion. And these are two independent 1D motions, and one does not affect the other, okay. So in the horizontal direction, what we observe is that the velocity is constant, because as we have already learned that the horizontal velocity does not care about gravity, and since there is no force acting along this direction, the velocity will be constant, or put in other words, there is no acceleration. But in the y-axis, we see that the gravity is acting downwards, okay, with minus g is the acceleration, since it is acting downwards. And there is an initial velocity, because if this is u, this will be something like u sine theta. This component will be u sine theta, and in the vertical direction, the motion will be exactly like that of a vertical projectile when you throw a ball up in the air, which you have probably studied in your class 9 standard, okay. So the first step in projectile motion is that we have to separate the motion into two parts, the horizontal motion and the vertical motion. In the horizontal motion, the velocity is constant, and in the vertical motion, it mimics the case of a vertical projectile where you throw something up and it falls down, okay. Now when we do some problems mathematically, we have to fix the initial conditions. In this case, the initial condition x naught equal to y naught equal to 0. In other words, we are choosing the coordinate axis in such a way that the point from which this was thrown, this point is chosen as the origin of the axis. Then this ux is equal to u cos theta. That means if this is u, then this will be u cos theta, right? The component along the x-axis. From the basic knowledge of trigonometry, you should be able to do this. This is the velocity, initial velocity in the horizontal direction, and this will be the initial velocity in the vertical direction given by u sine theta, okay. These are the initial conditions, and the equations that we have to use are the equations of motion, where v is equal to u plus at and x equal to x naught plus ut plus half at square. So you must have learned this as s equal to ut plus half at square, where x naught is some initial displacement. Moving forward, the key quantities. What are the key quantities that we have to calculate in this topic? In the x direction, we know that the horizontal velocity Vx is given by u cos theta naught, where theta naught is the initial angular projection. Mind you, this is not theta, this is theta naught, the initial angular projection. As this ball moves about, this theta will constantly change. So theta naught is the initial projection angle, and the initial horizontal velocity will be given by u cos theta naught, because if this is u, then this will be u cos theta naught, and this is not going to change because there is no force in the horizontal direction. So the displacement in the horizontal direction will be, displacement is equal to velocity into time. Velocity is given by u cos theta naught into time. So at any point of time, the horizontal displacement will be given by this. Now let's talk about the vertical displacement. In the vertical direction, since there is an acceleration minus g, so we have to use the equations of motion, that is v is equal to u plus at and s equal to ut plus half at square. Using that, you can see that v, this is a velocity in the vertical direction, that is equal to u plus at. This is minus because, as you can see, the acceleration is minus g, because this was going upward and acceleration is acting downward. So that's the reason this is minus. So this entire thing is like your u. So this is v is equal to u minus gt. U sine theta naught, because now we are dealing separately with this component, not with this entire u, but this component is u sine theta naught. Okay, and your vertical displacement will be given by y is equal to u, this is your initial velocity, s equal to ut plus half at square. So this entire thing is now your vertical velocity, u sine theta naught t minus half gt square. So once we are done in finding the horizontal displacement as well as the vertical displacement, all we have to do is, using vector sum, we have to find a net displacement that will be given by root over x square plus y square. This is nothing but Pythagoras. And similarly in the velocity also, the velocity will be vx square plus vy square, because the horizontal velocity and the vertical velocities, they are perpendicular to each other. Now let us calculate some of the important quantities in this regard. The first is the time of flight. That means from this point to this point, what is the time that it will take for the ball to come from the initial point to the final point when the ball lands on the surface of the earth. Now we know that the equation of for the vertical distance, that means y is equal to u sine theta naught minus half gt square. This we have done in the previous slide, this equation. So now we know that at this point as well as at this point, the vertical displacement is 0, because they are on the x-axis. When some points are on the x-axis, the vertical distance is 0. So that means if we put y equal to 0 in this and solve this, we will find that this is a quadratic equation. This will have two solutions. One solution is your t equal to 0. T equal to 0 means it is indicating the starting point. And the other solution is your t is given by twice u sine theta naught by g. So that is the total time that this will take to undergo the journey. Now what is also asked is the half time, or that means the time it takes from the lowest point to the highest point. So this entire journey takes t amount of time, then from here to here it will take t by 2, and from the highest point back to this it will again take t by 2. This time is called time of ascent and this time is called time of descent, and that is nothing but just half of this quantity. So this 2 will go off, so this will be u sine theta naught by g. Moving ahead, what is the range of the flight? By range, what I mean is this: if I start a projectile at this point, how far it will go, or like what is the distance between the starting point and the final point. So this distance is what is called as range. How do we find a range? We know that the horizontal velocity u cos theta naught, this always remains constant. So if we have the velocity and we have the time, we can find the distance, right? So that's time we have from the previous slide. This is the time, the total time that it takes. So if we multiply the horizontal velocity with the total time, we will find the range of this projectile, how far from the initial point the ball will land on the surface of the earth. So this is the velocity into time. Time is twice u sine theta naught by g. This will give the range as u square sine 2 theta naught by g. The next quantity of interest is how high the projectile will go, or how high the ball will go. So you will see that this is the highest point where it goes, and at this point the vertical velocity will be 0, and then it will start increasing in this direction. Okay, so if we want to find this height, how do we find this height? We know that at the highest point the vertical velocity is 0. If you have studied the vertical projectile, you have seen that a ball goes up, at this point the velocity is 0 and then it comes back. The same thing is happening here. At this point the vertical component of velocity is 0. We have seen that this vertical velocity is given by initial velocity minus gt, and if this has to be 0, then this time will be given by u sine theta naught by g. Now this is nothing but the time of ascent. Okay, if we use this time in the displacement equation, that is s equal to ut plus half at square, and if we put this t is equal to u sine theta naught by g, then we will find that the total height is nothing but u square sine square theta naught by 2g. So the maximum height, how much the ball will go, that depends on your initial velocity, the angle of projection, and the acceleration due to gravity. So these are the important quantities that are asked. One is the time of flight, the other is the range of flight, and what is the maximum height the projectile will go. Finally, let's talk about the equation of the trajectory. Like this is the trajectory that we are seeing. Now what is the equation of this trajectory if we want to find? We firstly know that in the x direction the displacement is given by velocity into time. This is the constant velocity, as I have been repeatedly saying. From this we can say that time is this. Time is equal to x divided by u cos theta naught. And in the vertical direction, what is happening is the equations of motion because of this constant acceleration g. So y is equal to ut minus half gt square. Instead of u, we are writing u sine theta naught because this is the vertical component now. U is the total velocity, but this is the vertical velocity and y is in the vertical direction. So from this equation, if we substitute the value of t here, we see that we get an equation like this. We get an equation like this. So this depends on the first power of x as well as on the second power of x. When we have something which goes to the second power of x, this equation is nothing but a parabolic equation. So that is the reason when we throw a ball up in the air with some initial velocity and an angular projection, the path it takes is a parabola. Why? Because our equation says this. It goes as a second power of x. So we can write this equation as y is equal to alpha x plus beta x square, where alpha is this part and the beta is this entire part. Okay, so we have seen why the trajectory that the parabola, that the projectile takes, is of parabolic nature, because the equation says so. So in summary, we can see that the main point that we have to remember in these kind of motions in a plane, that is a projectile motion, is this: instead of treating our problems as a 2D motion, 2D motion means we have to use the equations of motion in vector form. In 2D we have to use the equations of motion in vector form. We cannot write v is equal to u plus at, we have to write v is equal to u plus at, all these things. Only in 1D we have the liberty to use the scalar forms of these equations, and it's always easy to deal with the scalar forms. So if we treat this problem as a 2D motion, we have to treat it vectorially, and that is going to make our lives difficult. So instead of treating it as a 2D problem, what we have to do is we just treat it as two independent 1D motions, one in the horizontal direction where there is no acceleration, and one in the vertical direction where there is acceleration due to gravity. And once we are done doing things separately, and finally we can just combine them by using vector addition rules. So let's see whatever we have studied till now, can we use this to solve some problems. So firstly, let's take this question. This was in JEE Mains 2020. Let's see how we can solve this problem in a quite easy way. A particle of mass m is projected with a speed u from the ground at an angle theta is equal to pi by 3. So that means it is getting projected with a speed u, and your angle of projection, that is theta naught, is 60 degree. Okay, 60 degree. When it has reached its maximum height, that means this point, time of ascent, at this point it collides inelastically. Inelastically means with whatever it is colliding, both of them have stick together, okay, with another particle with the same mass and velocity u I kept. Now firstly tell me, at this point what will be the velocity of this particle? We know that if this is u, then this will be u cos 60. U cos 60, cos 60 is half, so this will be u by 2. And we know from our previous knowledge that the horizontal component always remains constant. So at this point its velocity will be u by 2. Is this fine? Because the horizontal component is always constant, and at this point, the highest point, mind you, there is no vertical component, because at the highest point the vertical velocity is 0. Now at this point it collides with another particle of the same mass. This is also m, this is also m, and it is moving with a speed of u. It is moving with a speed of u. Now these two will stick together and move, because this is inelastic collision. This is inelastic collisions, means this will stick together. Now if we use the momentum conservation here, momentum means mass into velocity, as you must already know this. Initial momentum is, this had a velocity of u, and the second particle had a velocity, that means the particle that we were throwing, that has a velocity of u by 2. This is the initial momentum, and this should be equal to the final momentum. After the collision, both this particle have stick together, that means the mass will be twice m, and let's say the velocity at which they move, this is v. We don't know what is this. So if we cancel all this m, we will find that your velocity will be 3 by 4 u. That means the velocity of this combined mass will be 3 by 4 u in the horizontal direction. Now it is asked, what is the horizontal distance that will be covered by this combined mass? So now from the highest point back to the ground, what is the time? The time is nothing but u sine theta naught by g, isn't it? This is the time. So if we want to find a horizontal distance, that will be nothing but velocity into time. Velocity is 3 by 4 u, and time is multiply, this is u sine theta naught, sine 60 is root 3 by 2, and u sine theta naught by g, so this will be g. So you can see that from this is the final expression. So this will be u into u will be u square, and 8 into 2 will be 8, 4 into 2 will be 8, so this is 3 root 3 by 8 u square. So this will be 3 root 3 by 8 u square by g. So we can see that how easily we can solve this. All we did is this, that just wrote down the momentum conservation equation and used the concept that at the highest point the horizontal velocity will remain same and the vertical component will be 0. Only using those 2-3 steps we can solve this. Let's take one more question. This is the last question for this lecture, and that actually came in JEE Advanced 2021. A projectile is thrown from a point O on the ground at an angle 45 degree from the vertical. So 45 degree from the vertical. So 45 degree from the vertical means 45 degree from the horizontal as well. So this is how a projectile is thrown, at 45 degree with a speed of 5 root 2 meter per second. So this initial speed is 5 root 2. The projectile at the highest point of its trajectory splits into 2 equal parts. That means if this is moving something like this, at the highest point it breaks down into 2 equal parts. But one thing that we have to know in this, that the trajectory will still be followed by the center of mass. Whether it breaks down to 2 equal parts or more number of equal parts, we doesn't care for that. But the thing is that if something is moving like this, the center of mass of the entire system will follow this projectile, will follow the original trajectory. Okay, one part falls vertically down to the ground. That means the first part will fall directly below at this point, and the second part, now since this is the center of mass, one part has fallen directly at this point, so the second part, the common sense will say that this will fall somewhere around here. Okay, the other part t seconds after the split falls to the ground at the distance x meters from the point O. So what we are asked is the value of time t. So this does not require any calculations, although by seeing so many numerical values you may be tempted to do some calculation, but this is not required. Why? Because we have learned that the vertical motion and the horizontal motion are independent of each other. So if one part takes 0.5 seconds to fall, that means this takes 0.5 second to fall, this will also take 0.5 second, because don't go by the vertical horizontal motion, because we have seen by drawing lines that at every point of time this and this will be along the same vertical height. So if this takes 0.5 seconds, this will also take 0.5 seconds. So this problem does not require any calculations at all if you understand the concepts properly. The next thing is the value of x is. X means what? From here to here, it said that the other part t seconds after the splitting falls to the ground at a distance x meters from the point O. So this is the point this is the point O. So this part falls at a distance, this much is your x, from the starting point to the final point where the other part has fallen. Okay, now how to find this x? It's quite simple. If this is the trajectory followed by the center of mass, that means this point is the center of mass of this and this. And since these are two equal parts, means what? This distance and this distance will be same. Okay, now we know in case of a projectile motion, if this entire distance is r, range, then this distance will be r by 2, this distance will also be r by 2. And now we have just clarified that this distance and this distance are equal. So this distance will also be r by 2. So the net distance x is nothing but 3r by 2. And we know that range is nothing but u square sine 2 theta by g. Okay. So u square is 25 into 2, that is 50. And sine 2 theta, sine 90 is 1, so we don't write it. And this will be 10, g is 10. So this will be 5 times. Okay, so 3 into 5 is 15, 15 by 2 is 7.5, so this will be 7.5. So all we have done is, if I'm just writing neatly here, this was the original trajectory. At this point it got splitted. If this fell down at this point and this will fall down somewhere here, these two distances will be equal because they are of equal masses. This distance is range from here to here, this is range. So this distance is range by 2, this is range by 2, and this is also range by 2. So the total distance will be thrice into range by 2. We know the formula for range, and from there we could calculate the value of x. So in this way we can solve the problems if we are very strong in understanding the concepts. And you see that in the problems in IIT JEE Advanced and Mains, they are not very lengthy. If you just have the concepts clear, just by writing 2-3 steps you can get to the solutions. So with this I'd like to conclude the class. Thank you so much for listening.